Welcome Pure Maths 1 students to week 11 of maintenance. The first question of the week, as usual, is a quadratics question, and we are finding the values of k for which kx squared minus 2kx plus 8 equals 0 has two distinct roots. Okay, now if it's got two distinct roots, then we know that the discriminant, or b squared minus 4ac, has to be greater than 0. So what we are going to do is work that out now. Now b squared, that's going to be minus 2k, because that's the coefficient there of the x, minus 4 times a, which is k, times c, which is 8. Now that's got to be greater than 0. Now what we get in actual fact is 4k squared minus 32k, ought to be greater than 0. Now I'm going to divide out that by 4, so I'll be left with k squared minus 8k is greater than 0. Now we can factorize at this point like this. Now if we were to sketch this, you can see that you've got a root at 0 and a root at 8, and so it's going to look something like this. And we want, where is it greater than 0? So when k is less than 0, or when k is greater than 8. And there we go. Now, a functions question. We're translating this quadratic to unites. It should be units. Two unites to the right. Find the equation of the resulting function. Okay, now we've got to give our answer in this form here. Okay, so when we're translating it to the right, that's a horizontal translation. So this is like doing fx minus 2, isn't it? Okay, that translates 2 units to the right. So what we do is everywhere there is an x, we're going to insert an x minus 2. So there and there. So what we'll get, it will be y equals x minus 2 all squared plus 5 into x minus 2. Now what we do there is we expand our bracket and then we expand the other bracket, 5x minus 10, and then we just got to gather all of our like terms to give them what they want, which was x squared minus plus x and minus 6. There we go. There's our functions question for the week. Easy peasy so far. Okay, we've got a circle geometry question next. Find the center and the radius. Okay, well, the center is at 0, 0, and the radius is equal to the square root of 16 or 4. Okay, now the next one is also a circle. We've got endpoints here, and we've got to find the equation of the circle. Okay, well, we want to find the center point. So, center is at the midpoint of those two, since they're diameters. So, we're going to go negative 6 plus 2, divide by 2. 8 plus negative 4, divide by 2, equals negative 4 over 2 is negative 2, and positive 4 over 2 is 2. So that's our center point, which means we've got half of what we need. So half of what we need is going to be x plus 2, that corresponds to this bit here, squared, plus y minus 2, and that corresponds to that one there, squared, equals, now we've got to find the radius squared. Okay, now, so to find the radius, we can find the length of the diameter. So the magnitude of this diameter is going to be the square root of the x change. So we've gone from minus 6. Let me just move this up a bit. Squared plus, and then the y change, so we've gone from 8 minus 4, and we square that. Now that is equal to the square root of, was that 64 plus 144, is that right? I think that's right. Now what does that equal when we chuck that in our calculator? Square root is 4 square root 13. Therefore the radius should be half of that, which is 2 square root 13. Now, in our formula, the right hand side is r squared, so we're going to take this and square it, and what do we get? We get so it'll be 4 times 13, because 2 squared is 4, and square root 13 squared is 13, so 4 times 13, which is 52. So I think we want 52 as our result for the right hand side there. Okay, well, on to the second page. We're doing circular measure. Now, what do we have here? Let's have a look. We have a diagram that shows two circles with radius r. Okay. The center of each circle lies on the circumference of the other circle. Okay, find in terms of r the exact area of the shaded region. Alright, so for this question of circular measure, we're trying to find the exact area of the shaded region. So one thing we could do is we could draw a sector like this red sector here. Find out what that is. Then we could draw another sector. I'll draw this with black from here, like this. And it would go along that red line there. Sorry, no, it wouldn't. Oops. It'll go around here. And what you'll see is if we work out both of those, the black sector and the red sector, then we'll have this bit, this diamond shape in the middle twice, right? That'll get counted twice, so we'll need to subtract that once. So what you can see is we've got two equilateral triangles. This is 60 degrees. This is 60. And this is 60. How do I know that? Well, and then same down here and here and here. Okay. How do I know that? Well, because of this. This is a radius. This is a radius. And this is a radius. Okay. So let's work out the area of the red sector. I know that that is 120 degrees. Okay. Now, we wanted to use radians for this. So I'm going to go, the red sector is equal to half times r squared times theta. Now theta in this case is, what is it? Well, it's like 120 degrees. So that is 2/3 pi. Right, and so that's the area. Remember, half r squared theta. That's the area of the red sector, and then the area of the black sector would be that again. So we times it by 2. Then we're going to take away this middle blue bit here, which is made up of two triangles, two equilateral triangles. 2 times half, and then all of these sides are r, so half a times b times sine 60, which is what 60 is, pi over 6. No, pi over 3, sorry. Okay, so you need to get good at converting, working with your different, with your radians there. So I guess we can say that this ends up being r squared, what is that? 2r squared pi over 3 minus r squared, and then sine pi over 3. So what is that? That gives us square root 3 over 2. I think that's a 3 there. And so I guess we want to factorize that by taking out the r squared. Oh, sorry, that's also a 3 there, isn't it? And then I guess we could take out this 3 here. I think I'm getting r squared over 3 into 2 pi minus square root 3. And I think that is the answer. Let me just quickly check over that now. So let's see, so this first bit here, half r squared theta now, we've got an angle of 120 degrees, or 2/3 pi. Yep. And then we've got 2 of those, so that's that. And then we've got these triangles that we've got to take out. Oh, here's where my issue is. I don't want to take out 2 of those triangles, do I? I want to take out 2 of them? Yes, I do. Yep, I do. I want to take it out. So I want to take out this triangle and this triangle because we're repeating it by doing both sectors. So yeah, 2 times 1/2 r squared sine pi over 3. Yep, that's looking good. Sine pi over 3. Okay, and then so the next line, when we work that out, we get 2 times 1/2 is, that gets rid of that, so we get 2/3 r squared pi. Yep, and then this one here we've got, whoops, what have we got there? Minus 2 times 1/2 is minus 1, so we get r squared times, what have we got there? Square root 3. Square root 3 over, oh no, it was actually a 2. My mistake. It was over 2. Okay, and so that means probably we just, when we factorize out, it'll be a bit different from that. So Take